Assalamualaikum and hello everyone. We proceed to the next subtopic 1.2 electric field. The first learning outcome, you should be able to define and use electric field strength, or another name for it is intensity. So in this subtopic, you need to know that every point charges creates an electric field. So setiap charge, positive or negative, it will create an electric field. So what is electric field? Electric field is a region where electric force is experienced. So let's say here we have positive charge. So this positive charge will create an electric field surrounding it. So this is what we call as electric field. So electric field ni dia akan ada direction juga. Kejap lagi kita akan tengok. So basically, setiap point di sini dan point di sini, they will experience different strength. So semakin dekat point tu dengan charge, semakin kuat the strength of the electric field. So the further away, the weaker the electric field strength. So let's say if we place another charge inside the region. So we place another positive charge inside the region. So this positive charge will experience electrostatic force. Okay, it will experience a force. Since it is positive, so positive jumpa positive, it will experience repulsive force. So they akan repel each other. So when they repel, meaning that the direction of the force will be going to the right. So sama juga untuk negative charge. So negative charge, dia juga akan ada region around it that we call as electric field. Okay, tak kisahlah positive charge, negative charge, adakah dia lebih daripada satu charge, will always have a region around it that we call as electric field. Okay, before we go through the definition of the electric field, let's look at the direction of the electric field. Okay, so this one adalah under learning outcome number 2, which is to sketch electric field strength diagram. So automatic kita kena tahulah direction in order to find in order to draw the diagram. Okay, so we have a few cases here. First is for single positive charge. So hanya ada satu sahaja positive charge. So the direction will be going outwards, okay, away from the positive charge with the arrow here. So mesti lukis macam ni. Will always go out from the positive charge. Ni adalah untuk single positive charge. Untuk negative charge, the direction will be going towards the negative charge, like this. And then the next one is when we have two equal charges of opposite sign. Okay, two equal charges of opposite sign, meaning that here we know that when positive bertemu dengan negative, they will attract each other. So apabila attract each other, the electric field direction sama juga still obey the same rules, which is away from positive towards the negative. Tetapi disebabkan mereka ada dua berdekatan kan, so kamu kena sambunglah line tu. Line dekat sini mesti sambung. And then next one we have two equal charges, positive. So positive, they will repel each other. So apabila repel each other, okay, they will go like this. Dia akan, line tu still akan keluar daripada positive charge, tetapi they will never meet each other lah, macam tu. Tidak boleh, because they repel each other. So the line here is what we call as neutral point. So this is the neutral point. So sama juga untuk negative. So kalau kita ada negative dan negative, the pattern is still the same. Cuma direction saja yang berbeza. So direction dekat sini, kalau dia negative, kamu kena ubah lah. Dia akan masuk towards negative. And then last one, we have two opposite charge inside the parallel metal plates. So kalau kita ada dua metal plates, satu positif, satu negatif, maksudnya banyak charge lah dekat dalam plate ni kan. So apa yang berlaku, it's still the same. The charge direction will be from positive to negative, but now we have a uniform electric field. So this one kita panggil dia sebagai uniform electric field. So this one kita akan tengok nanti dekat subtopic 1.4. Okay, so in your notes, ada kotak kosong Miss tinggalkan. So kamu kena lukislah semua ni, because this one is important. You need to be able to know how to sketch the electric field diagram. Okay, so the characteristic of electric field lines here. First is the field lines indicate the direction of the electric field. So obviously the line here maksudnya they indicate dia adalah direction. So untuk positive, it's going outward, going away from the positive. So untuk negative, going inward, going towards the negative. Next one, the lines are drawn so that the magnitude of electric field is proportional to the number of lines crossing per unit area perpendicular to the lines. The closer the lines, the stronger the field. Okay, so maksudnya dekat sini, the higher the charge, the bigger the charge. So contohlah charge tu, if we compare two charge, okay, kalau kita ada dua positive charge, okay, let's say lah they're not next to each other. Kedua-duanya adalah single positive charge. Okay, tetapi satu 10 microcoulomb, satu 10 coulomb. So the pattern will be like this juga. Dia akan ada direction going outwards, tetapi the lines will be different. Sebab dia cakap dekat sini, the magnitude of electric field is proportional to the number of lines. So maksudnya untuk 10 coulomb, lines dia lebih banyak berbanding untuk 10 microcoulomb. So mungkin line dia ada 4 je, macam tu lah. Okay, next one, electric field lines start on positive charges and end on negative charges. So it starts on positive charge and then going towards the negative charge. And then last one, the field lines never cross because the electric field don't have two values at the same point. So the lines here cannot cross each other. Okay, dia tidak boleh bertindih lah, akan ada satu lagi macam ni. No. Okay, mesti akan ada gap between the two lines. And the area where the lines are closer to each other, macam ni kan, they are closer to each other compared to the point here. So the area where they are closer to each other, it will have a stronger electric field strength, okay, compared to at point here. Okay, now let's look at the definition of electric field. Electric field strength at a point is defined as the electric force per unit positive charge that acts at that point in the same direction as the force. So basically the definition here, we can translate it to the equation of electric field. So E here stands for electric field, the symbol for electric field strength. It is equal to force per unit charge. So since force is equal to KQQ divided by R square, so apabila kita substitute dekat sini, and then kita boleh cancel out this Q. So Q ni adalah the test charge. So kita boleh dapatkan a new equation which is equal to KQ divided by R square. Dan Q di sini, the charge, we only need to substitute the magnitude. So negative sign tidak perlu include. Sama juga macam force. And the distance here is the distance between a point and a charge. So contoh lah, we want to find what is the electric field here. What is the electric field at this point here? So the distance from the point to the charge is the value for R here. Or we can also use another equation in terms of permittivity. So sama juga Q is the magnitude of a point charge divided by 4 pi E naught. E naught is the permittivity, so it's a constant value, or usually given in the list of constant, and R square. And since force adalah Newton and charge is Coulomb, so the unit for electric field is Newton per Coulomb, or we can also use volt per meter, but usually kita gunakan this unit. Okay, so we will look at how to apply this equation in the next video, in the example video. That's all for 1.2.